molecule is not formed into the process. It's just the addition of the monomers, and that is why it is going to continue ahead. Now let us see here. Polymer product is formed rapidly in the process. It means what? Whenever addition technique is adapted to for any polymer, then we get the final product very fast compared to our this different type of the technique. Let us see here, thermoplastics are there. Okay, thermoplastic, as discussed in the earlier cases, they are basically prepared by this technique. Which technique? That is addition polymerization technique. Now you all are very well aware what are thermoplastics, so I will not take that, but thermoplastics are prepared by this addition technique that one has to keep in mind. So what are the plus points there? What are the specifications regarding addition polymerization? It requires the presence of double bond. There is no byproduct formation. It is just the simple addition. Then you can see here polymer product is formed very rapidly in the process. You can see here mostly thermoplastics are prepared by this method that one has to remember. An example you can take, that is your polyethylene formation that we have seen in the reaction. Let us move ahead to the condensation polymerization, that is the second type. Now what is this condensation polymerization? Okay, see, look here, it requires the presence of reactive functional groups. So what does it specifies? The functional group detail that I have given it in the starting of the session, that indicates that we need to have two reactive functional groups present in our monomer. Then only then we can carry out this condensation polymerization reaction. Now how can we draw? Let us try to take the example. Second is our condensation polymerization. Okay, if you look here, then what we can draw for this example, basically, that is condensation polymerization. Example is formation of your nylon. Okay, formation of nylon. So for that we have to see what are the monomers. Basically the monomers that are taken is, I am drawing the structure CH2 6 times NH2 NH2. Okay, you can see here in the reaction process, that is we have this compound that is known as hexamethylene. You can see here hexamethylene diamine. This is the compound, okay, that we are taking. This is one of the monomer to form our nylon. The second compound that we are taking is basically adipic acid. Adipic acid is having the structure like this. Okay, you can see here it is having the structure of this. So you can see the name adipic acid and hexamethylene diamine, which is known as HMDA. These two are basically the monomers. Okay, now what happens when these monomers are reacting? What is going to happen? What is the product? If you see very clearly here, then you can see there is NH2 group available here. This is one of the reactive group, that is amine group. If you see here, there is carboxylic acid group, that is another reactive functional group. Now what happens? There is a reaction between amine group and carboxylic acid group. So in this combination of the monomers, there is a loss of a neutral molecule like water. Let us try to write down the reaction for this. We can see here that we have seen condensation polymerization required the presence of reactive functional group, right? So what does that says? That the functional groups, like you have aldehyde, amine, carboxylic acid, all these are the functional group. Their presence, at least minimum 2 functional groups should be present into the monomer to form the reaction of the condensation technique. Now here we have specified that there is a byproduct formation. Okay, why there is byproduct formation? Because there is a loss of the neutral molecule. And why neutral molecule is getting lost? Because there is a reaction between two reactive functional group. That is why the byproduct is formed into the reaction. You can see the another thing, that is polymer product is formed slowly in this technique. So condensation polymerization basically here is responsible to form the polymer very slowly in the process. Now you can also see thermosetting plastics are prepared by this technique, that is condensation techniques used to make thermosetting plastic. Let us try to continue with the nylon reaction. What was it? Look here, we have the reactions between two compounds. Okay, formation of nylon, that is you can see here very clearly you have one functional group that was like this. Okay, this is one thing, that is hexamethylene diamine. This is HMDA, hexamethylene diamine. Then with this we are going to add another monomer, that is adipic acid. So you can write here adipic acid structure is like this. Now as I told that condensation polymerization requires presence of two reactive functional group. So you can clearly say here that condensation polymerization, now we have two monomers to form nylon, HMDA, and we have adipic acid formation. Okay, so now you can see very clearly how we will do the reaction. This NH2 group is there, okay, and this NH2 group is basically going to react with carboxylic acid group. Okay, carboxylic acid group is there. So now look here, from this NH2 group one hydrogen is getting lost, and from this carboxylic group OH is getting lost. Okay, so now I can write the reaction something like this. Just have a look, NH2 is there, hydrogen is getting lost from NH2, so I will write here NH. Okay, and from carboxylic group OH is getting lost, so I will write here CO. And now you can see here rest things are getting clear as it was there earlier. So now what happens, this chain is further going to continue, that's why we are showing it like this. Okay, so this is the full-fledged reaction. Now if you see this group, CONH group is getting repeated in the structure of the nylon. Okay, this is your nylon 6,6, and that is why it is the example of the polyamide. Okay, polyamide it is known as, because your CONH group, that is amide group, is getting repeatedly in the entire polymer chain. Condensation polymerization technique is used to make the polymers like nylon. Nylons are having the monomer of HMDA, that is hexamethylene diamine, and adipic acid. Both the monomers are combining together. In this process neutral molecule is eliminated out. Neutral molecule that is eliminated now will be written here that is minus water. Okay, it means what? That water is lost in the process. How water is lost? One hydrogen from here, OH from here, so OH and H will give rise to H2O here. So you can see very clearly that there is a formation of nylon 6,6 in the process, that is basically example of your polyamide. So now let us try to compare both the techniques. We have seen earlier addition polymerization technique required the presence of double bond, but condensation polymerization technique required the presence of reactive functional group, which has to be present in the monomers. If you see the second point, no byproduct is formed in the process, but in condensation polymerization byproduct is formed, for example water molecule in case of nylon formation. Then you can see in addition polymer product is formed very rapidly, and if you see condensation polymerization, polymer product is formed very slowly. If you see here thermoplastics, okay, we have discussed thermoplastics are basically prepared by this addition technique, and here thermosetting plastics are prepared by this condensation technique. Okay, now let us try to take the examples. What are the examples of the thermoplastic? The day-to-day applications that we are finding in the polymer zone is widely used polymers are this one. You have polyethylene, that is your polymer bag that you are taking, polypropylene, then you have Teflon, the non-sticks that we are using, polystyrene polymer, and we have Orlon. These are the examples of basically your thermoplastics. Thermoplastics, according to the different properties, they are finding their special applications, and then we can go ahead with this polyethylene properties. That is the first polymer in the list, that is polyethylene. Okay, so we'll see here polyethylene. Again, it is classified into two different parts, that is low density polyethylene and high density polyethylene. Okay, these are the two types of polyethylene. Now both are having very different property. If you see there, low density polyethylene is tough and flexible at low temperature, but when you see high density polyethylene, it is more hard and stiff compared to your low density polyethylene. So these are the properties that one has to keep in mind while discussing the polyethylene case. That is, it is classified in the two cases, low density polyethylene and high density polyethylene. Then you have low density polyethylene is basically flexible at room temperature. You have high density polyethylene, basically it is hard, stiff compared to your low density polyethylene. Let us try to see what are the applications of the polyethylene, why they are very much popular. They are finding the special uses, special applications in the different types of the things that we are using in daily life. Low density polyethylene is used as a film for general packing. The packing that we are doing of different goods and all that things, basically for that low density polyethylene film is used. Okay, then it is used to make carrier bags, the bags that we carry. Okay, polyethylene bags. Then in molded toys, in tubes and mugs. High density polyethylene is used to pack food products. The food products can be packed with the high density polyethylene. Again it is used, polyethylene is again finding application in gas and water piping, the pipes of the gas lines and water lines. For that it finds a special application in industry to make the milk bottles, water bottles, all the things. So these are the applications of the polyethylene. Moving to the another polymer, that is very important polymer, that is PVC. The word PVC stands for polyvinyl chloride. Polyvinyl chloride is the another polymer that is also very important, finding important application in daily life. If you see here, PVC plastics is basically colorless, odorless and non-inflammable. It is resistant to chemicals, so it is finding special application in the industries. Then it has excellent oil resistance. Then the next thing, that is this PVC basically acts as a good insulator. Okay, it is having good insulator properties and it is waterproof. So these all the things are finding very importantly in this particular polymer, and hence it is having specific uses that are, if you see here, PVC is used to make drainage pipes and water supply pipes. Then it is used to make car applications in upholstery, bathroom curtains, purses, handbags. Okay, it finds the application in these things, and as it is waterproof, so it is used to make raincoats and shoes that can be worn in the special rainy seasons. So PVC, that is polyvinyl chloride, okay, these things are finding very important application, that is it is having colorless, odorless, resistant to oil, resistance to chemicals, acting as a good insulator, hence it can be used to make the drainage pipes, water supply pipes, finding applications in the raincoat, shoes because of the special quality. Let us see the next polymer. If you see here, Teflon. Teflon is having a name of polytetrafluoroethylene. Polytetrafluoroethylene is having a very excellent properties, very extraordinary properties. That is, it is having high density, chemically inert over wide range. Okay, so it can be operated with different chemicals up to certain ranges. Then you have, see, chemically inert, that means what? Basically, whenever you are carrying out any chemical reactions in the industries at particular temperature, then what happens? As I told, that there are chances polymer properties may change, but this Teflon is finding special application that it can be used safely in the wide temperature ranges because it is chemically inert over the wide temperature range. Then again, this Teflon is a good insulator. Then we have Teflon is having non-adhesive properties, very important. This non-adhesive properties basically that is helping Teflon to prepare the extra special non-sticks that are used for cooking in daily life. Okay, then the Teflon is having excellent toughness and heat resistant properties. So one of the important property, that is non-adhesivity, extra toughness, heat resistant, chemically inert, is making Teflon a very particular apart from all the other polymers. Let us see next applications of the Teflon, or you can say application of the polytetrafluoroethylene. If you see here, polytetrafluoroethylene is basically used in wire and cable insulation. Okay, then you can see here coating for frying pans. It means, as I told, as it is having non-adhesive property, so they are used to coat the frying pans and we can easily cook the vegetables on that. Then the Teflon finds non-lubricating bearing coating. Okay, on the non-lubricating bearings, Teflon is finding the application. Then it is used in packing valves, pump parts, etc. We'll continue in the next session the rest applications. Thanks for being with us.